Okay, so here we are with the second example, connected this with this little exercise here. And again, the key thing is, let's begin by reading the question. The diagram shows a particle in equilibrium. So remember, that's the key fact that's attached with that. What would that be? Nick, can you remember that? Yeah, okay, that must be equilibrium, resultant force in any direction is equal to 0. Yeah, that's the key thing that we have to remember. Okay, the diagram shows a particle in equilibrium on an inclined plane under the forces shown. Find the magnitude of the force P and the size of the angle alpha. Okay, so we've done stuff like this before, and we know that the key thing to do at the beginning is to resolve the forces into their components. Right? But we've got a big decision to make here. What directions are we going to work in? Well, we know that the standard directions to work in are what? Can you remember? William, have you got that? Yeah. Parallel and perpendicular to the plane. Work parallel and perpendicular to the plane. Now, often the plane is horizontal, so it would be horizontal and vertical, but here it isn't. So first of all, let's look at that 5 newtons component. Don't draw small diagrams. Make sure that you can put the forces, the angles on and the components nice and clearly. So if this is 30 degrees, that's 60 degrees. So we tend then to put in our component forces relative to the 30-degree angle, the angle at which the slope is. So adjacent, we get 5 cos of 30, because that is adjacent, and here 5 sine 30. Did you notice that I've actually learned to do something new on the iPad? And make that a little bit larger so it's clearer. Okay, over here we've got P. I'm going to do these in the same colours, so I'm just going to undo that, sorry. So in that direction, yeah, this is going to be P P cos of 30, because that's adjacent to the angle. So P cos of 30, and here we've got P sine, and that should be alpha, not 30 down there as well, shouldn't it? So P cos of alpha. Okay. So, what are we going to do? We have got to now work parallel and perpendicular to the plane. So let's resolve parallel to the plane and up the plane. We get P cos of alpha minus 5 sine of 30. Have we got anything else in that direction? We've got the 8 newtons. Nearly missed that. Is equal to 0 since equilibrium. Yeah. So let's just make it clear where those have all come from. So those ones are here, here, and here. Okay, if we tidy that up a bit, we've got P cos alpha equals 8 plus 5, and sine of 30 is a half. So we've got 16 plus 5 is 21 over 2. Okay, now we're going to resolve perpendicular to a plane. When we do that, we'll go back to the diagram and let's see which forces we need to pick out here. So these are perpendicular, perpendicular and perpendicular. So we're going to have 2 plus P sine alpha, P sine of alpha minus 5 cos 30 equals 0 since equilibrium. Okay, so what do we now have? Tidy that up. P sine alpha equals 5 cos 30 minus 2. We know cos of 30 is root 3 over 2, so 5 over 2 root 3 minus 2. Simplifying that, so we've got a common denominator, we've got 5 root 3 minus 4 all over 2. Okay, so we've now got, well, what have we got? What do you notice about these two equations? Here and here, in effect. We should pick up on something here. Yeah, this is 2 equations, 2 unknowns. So that tells us that we can solve this simultaneously. Right, and there's one quite neat way to do that. Anybody spot it? Harvey, any idea? Anybody else? Okay, let's have a look. So we can put P sine alpha divided by P cos alpha. We could have just made P the subject, but if we do that, it's just a little bit easier and quicker to do the calculation. So we take P sine alpha, which is equal to 5 root 3 minus 4 all over 2, and divide it by P cos alpha, which is 21 over 2. Yeah, although they look different, we are dividing both sides by the same thing, because these 2 bits are the same. They're equal, aren't they? From above. Yeah, we've got P cos alpha equals 21 over 2. So although we've written different things down here, yeah, we're actually dividing by the same thing. So the P's now cancel. So we now got one unknown, which we can now write as tan alpha. Sine alpha over cos alpha. The one unknown is alpha, but we can write that as tan alpha now. Divided by a fraction, invert and multiply. So the divide by 2's in effect cancel to leave 5 root 3 minus 4 over 21. Yeah, piece of factual knowledge that we should have from ages ago. A over B divided by C over D is equal to AD over BC. And that again is something that we should have learnt. Yeah, very useful little bit of factual knowledge. Okay, so we're now going to simplify that. Alpha equals arc, well, find alpha, so alpha equals arc tan of 5 root 3 minus 4 over 21. Well, you'll need a calculator for that. 5 root 3 minus 4. 5 root 3 is going to be roughly, I don't know, 8-ish. Minus 4 is 4-ish, so it's about a fifth. Arctan of about a fifth. It's going to come out to be around 12, 13 degrees. But you can tap it in a calculator and see what you get. Just check the exact value. Once we've got alpha, we can substitute back into the one of the earlier equations. So we know P cos alpha equals 21 over 2. So we substitute back in, sub in, I'll call it capital A. So let's go back here, find the easiest one. We'll call that A. So P cos alpha equals 10.5. So P cos of alpha equals 10.5. Make sure you use your exact value for alpha. And P, tap it in the calculator and you should get about 11. So something around 11 newtons. And again, you can check the exact detail. Hope that helps. Homework attached for that should be relatively straightforward because we've done quite a lot of build-up work and work that's similar to this earlier in the course. So exercise 7A, questions 1, 2 and 3. Check the answers in the back and leave me a note on the VLE, please, just to let me know how you've got on. Okay, cheers.